This is the teardown procedure for the Fleck 2850 valve. On this side, we have our designer cover and mechanical controller. On this side, we show our metered control with the electronic NXT controller, as well as our environmental cover. As we rotate the valves to the side, we can see that this is what we would refer to as a flat cap unit, or one without an injector system. This would be our filter valve. We also notice between the back plate of the control and the body of the valve, there is no spacer. This would mean that this is a hard water bypass unit. Moving to the other unit, we can see we have an injection system on here, as well as our meter assembly. This is our taller 1700 injector system for use on tanks above 24 but below 36 inch. For the purposes of our demonstration, we are going to focus on this electronic unit. If we should need to check the meter, we can remove the screw from the cap. We can use a slotted screwdriver or a 3/16 driver. With the screw removed, we can access the cable end. To test if the meter is working, we can wave a magnet across the end. This should register flow on the front of the controller. If it registers flow, the cable and the control are working properly. So we could remove the cap to make sure there is no dirt or debris holding the impeller. If it does not register flow, we would want to check all the connections between the cable and the control. Moving to the meter, we can see on the back of the valve there's a connector that goes from the valve body to the union to the meter. To remove the meter, we loosen the nut at the union. Once this is removed, we can see there is an O-ring that seals between the meter and the connector. Inside the meter assembly, you will find the flow straightener. This redirects flow of water to the center of the paddle inside the meter assembly. We can then unthread the connector from the valve body. As we move to the front of the valve, we can see our environmental cover is held on with a screw. Using either a 7/16 driver or a slotted screwdriver, we loosen the screw. We can then rotate the cover out of the way. If we need to remove the cover, we pull up on the hinge pin and the unit is removed. This gives us access to the controller. Using a 3/16 driver or a slotted screwdriver, we can loosen the screw. With the screw loose, we can rotate the controller out of the way. With the power off, we can remove our cables from the bottom of the controller. If you have a metered unit, the first thing you can remove is the 3-pin connector. Moving over, the next two wires, the black and the white, are the 24-volt AC supply. Pressing up on the tab and down on the wire will allow it to be removed. Doing the same for the second wire. This then gives us access to the 5-wire assembly for the limit switches and the power drive motor. We can then move to removing the controller from the hinge. We pull up on the pin and hold on to the O-ring on the bottom. We can then grab onto the controller as we lift the pin out. With that removed, we can move to the brine assembly on the rear. This particular assembly has the injector in the top, followed down by a J-tube to our brine valve. To remove, we begin by loosening the two nuts that hold the J-tube between the injector housing and the brine valve. Loosen the brass nuts with a 13/16 wrench and the plastic nuts with a 15/16 wrench. Once the nuts are loose, you can pull the J-tube to the rear of the unit. This will give us access to the injector assembly at the top. Using a 1/4-inch driver or a slotted screwdriver, we can loosen the two screws. On the top plate, we will see that there is a number 3 stamped into this. Inside we can see where the injector is, but on the 1700 system there is no screen. On the bottom side of the injector assembly, we have our regular gasket, but we also have the flow disperser at the bottom. This may be on the bottom of the injector assembly, or inside the body. Make sure you only have one piece or you will cause damage. To remove the injector, grab onto one of the tabs. For the bottom half of the injector, it is easier to use a spare injector to press down from the top. This will allow you to pull the injector out of the bottom half without causing any damage to the orifice. If we should need to replace the injector, we want to make sure that we match the color and material. Both the 16 and 1700 have different colors for different flow capacities as well as tank diameters. We want to make sure that if we do a replacement, we use the same color and material. You can also choose to order the injector as an assembly. This will include your top cap, which identifies which injector, your flow disperser, and any required gasketing. Once we have our injector assembly out, we can then move over to our brine valve. For the 1710 assembly, we will use a 7/8 wrench in order to loosen the nut. Once this is loose, we pull the valve from the back side. We want to use caution not to cause any damage to the coated gray material. This particular brine valve is a 1710 and is a 1 gallon per minute refill flow control. If we should need to replace it, we want to match that brine line flow control. If we cannot match it, such as this unit that is a 3 gallon per minute, we would need to change the brine refill cycle. With the 1700 system, we also have the 1700 brass valves. Either one can be used, just making sure we match our brine line flow control. If you are using a 24-inch or smaller diameter tank, you would use either the 1600 or the 1650 brine valve. These would be coupled with the 1600 injector assembly. The 1600 assembly is easy to identify as the throat and nozzle assembly thread in, compared to the 1700 where they press in. You can also choose to replace the injector assembly as an assembled part. This side shows our plastic assembly. This side shows our hot water brass assembly. Both of them you can see have the number 2 stamped into the top to tell you which pressure of operation and which tank size they are for. If you should have a filter assembly, you will have the cap, gasket, and 2 screws. On the drive assembly, we can see we have 2 limit switches. The red limit switch that's closer to the drive assembly is our homing switch. The white limit switch is our position switch. Between the 2 switches, it communicates between the drive assembly and the controller for what position the piston is in. These limit switches ride on the blue cam that is below. If we follow the blue cam over, we can see there is a link that goes between the piston shaft and the drive assembly. If we should need to separate these, we pull the pin that goes between the piston and the drive link. Once this is removed, we can remove the 2 screws that hold the drive assembly and back plate to the valve. Using either a 7/16 nut driver, ratchet, or slotted screwdriver, we loosen these screws. While loosening, we want to use care to not damage any of the gray coating that is on the piston shaft. Once the screws are off, we can remove the drive assembly and clear the back plate. We now have access to the piston assembly. Bringing our drive pin link back into the piston shaft, we can pull forward to remove the piston. Once the piston is removed, we have access to remove the seals and spacers. Using a hook tool for the seals, we can pull them out. We then bring in our spacer puller tool. We put this in the bore of the piston and press down on the lever. There are 3 pins in the lever that hold into the holes of the spacer. Pulling it loose, we can then remove the spacer. We repeat by using the hook tool for all of the seals and the puller tool for all of the spacers. As we pull out the last seal, we should have 6 seals and 5 spacers. Once the body is free of the seals and spacers, we can reinstall a new set. We have 3 options. One that uses brass spacers and our standard seal material, a second that uses plastic spacers and the same standard seal material, or one that uses plastic spacers and a more chemical resistant seal material. We can identify the more chemical resistant seal material because it is marked with a color on the inside. To begin the reinstallation, we take our new seal and spacer kit, we bring in our approved silicone lubricant, and our stuffer tool. To begin, we take a small amount of the silicone lubricant and apply it to the first seal. We place this into the metal end of the stuffer tool. We then place it into the bore of the valve. We take our spacer, flip the tool around, and press it into the body. We continue on, alternating, adding lubricant to the seals and adding the remaining spacers. As we add our final seal, we can see that the seals and spacers do not go all the way to the end of the valve. This allows space for the end cap of the piston. We need to choose which piston we are going to use. We want to match what the unit was originally built with. We have ones with brass end caps, which are rated for hot water, ones with black end caps, which are for no hard water bypass, will also have a white spacer, or our hard water bypass piston, which has a white end cap. For our application, we'll use the same white hard water bypass piston that we originally had installed. To install the piston, we apply a small amount of the same silicone lubricant to the O-ring on the outside of the cap. We press the piston into the center and press down on the end cap to seat it in the body. The end cap will sit out from the valve and will compress when the back plate and drive assembly are tensioned. The remainder of the reassembly is the reverse of removal. We've just completed the teardown procedure on the 2850. The 2850 is available in 2 valve bodies. We have the 2850 and the 2850S. From the front, they are not identifiable. On the 2850, we can see that we have male threads. This is going to be 1 inch. On the 2850S, the threads are female and it is 1.25 inches. Another identifier is that between the back plate of the valve and the body of the valve, you may not have a spacer on the 2850. You would have a black block if it is a 2850 with no hard water bypass, but you would not have one, such as this example, with a hard water bypass. On the 2850S, you will always have a spacer. It'll be black for no hard water bypass, white for hard water bypass, or a gold color for hot water. The other thing you can do to identify a unit is if you loosen the cover on a 2850. The 2850S will have a gray cam, whereas the standard 2850 will be a blue cam. The components inside the 2850 and 2850S are different. We can see that the diameter between the 2850 and the 2850S are of a different size as well as width. So we need to make sure when we do replacement parts we select the right kit. In the front we have our 3 kits that are available for seals and spacers for the 2850. In the rear we have the 2850S seal and spacer kits. They use different stuffer and puller tools for the 2850 versus the 2850S. We can also see that the diameters of the pistons are of a different size. This is our 2850. The one with the triangle end cap is our 2850S. We have those available in our hard water bypass with the white end cap, hot water with the brass end cap or colored end cap for the 2850S, or the black end cap for the no hard water bypass option. We still use the same silicone lubricant for all of the seals and spacer sets, but we want to make sure you select the right piston, seals, and spacers for your installation. The 2750 and 2850 can be transitioned from a hard water bypass to a no hard water bypass application. To do that, you want to make sure you select a kit. On this side, we have our 2750 kit that has the right diameter for that piston, as well as the tubes for a 1600 and 1700 system. It also has the longer screws to accommodate the extra length that the spacer adds. For the 2850, we have a 1600 and a 1700 kit that are separate. They do include all of the rest of the components you would need. Thanks for watching.